Hello everyone. I'm discussing a very important part of organic chemistry today for class 11 specifically, that is the conversions. Many students get confused about the conversions because the simple concept is that if I have done organic chemistry thoroughly from NCRT by writing everything, only then I will be able to do conversions in the end. When I'm very sure that I remember all the concepts, all the reasoning which is given in the chapter, all the name reactions and everything, only then we can do conversions successfully. So let us try a few conversions, simple ones I have taken from your syllabus, class 11 students. So let's get started. The first conversion that I would like to discuss is propene to propane. And first thing that we must do whenever we are trying any conversion is we must draw the structure of the compound. Like if I take this one, you have propene, right? So I will be making propene. Propene is, I'll take different color. Yeah. So I am taking propene and I have to convert it to propane as you can see here. So once you draw the structure, it becomes very clear and easy that we just have to convert the double bond to a single bond here. For that I will be adding hydrogen to it in the presence of a catalyst like nickel or platinum or palladium, as simple as that. Ethene to ethane, propene to propane, basically any alkene can be converted to corresponding alkane just by carrying out hydrogenation. So purposely I am starting with a very simple conversion. This is the first one. Now when we try for propine, the second conversion, what are we supposed to do? We are supposed to convert propine to propane. Again, same concept. Prop means 3 carbons and that means a triple bond. So I'm making a triple bond C and then CH3. This is propine and I have to convert it to propane. Right. Again, same thing is happening. I just have to convert unsaturation to saturation basically as we did in the first conversion. So here also I will be simply providing hydrogen in excess in the presence of nickel, platinum or palladium as catalyst and I will get the results. In some of the books you will find that they write 2H2 plus 2H2 here. So it doesn't matter because here in organic chemistry, even if you do not write the balanced equation, it is accepted. And if you write balanced, then also it is good. So anyhow, you can show it, you can write it like this in the presence of catalyst and the result will be the saturated hydrocarbon. The reaction will proceed via alkene only. First, this will convert to a double bond by addition of one hydrogen to it. And then one more hydrogen molecule will add to give you the final product, that is alkane. Simple conversion. Now, let us try next one. Chloromethane to ethane. So, we'll be drawing the structure first. Chloromethane, that is, will be writing the formula CH3Cl and I have to convert it to ethane. Now it is very clear that the number of carbons are doubling. Here I have 1 carbon and in the product I have 2 carbon. So immediately it should come to our minds that in a particular name reaction the number of carbons double. And that is Wood's reaction. So what will I do here? I will be taking sodium metal with, yeah, I'll be taking sodium metal in the presence of dry ether. I hope you know the reason here why dry ether as a solvent, because water cannot be taken here. Ether with some moisture is also a big no. Why? Because sodium reacts vigorously with moisture, with water. So we cannot take sodium with any solvent which has water in it. So we take ether, absolutely dry ether, and the number of carbons will double. Simple conversion from chloromethane, I have got ethane just by single step. Conversions may have more than one step. In your NCRT, you will find a solved example where at least 10 steps are there in the conversion. So that is good for practice. I have taken some parts out of it here. I'll be discussing them. But such long conversions having so many steps, they are not asked even for class 12th board exams. But that is very good for practice. Okay. Now the next conversion is chloroethane to ethane. So chloroethane, that is CH3, CH2, Cl, and I have to convert it to ethane, CH3, CH3. Now what I have to do exactly, I have to basically get rid of the Cl, and in place of Cl I should have a hydrogen, so that CH3 is obtained here also. So think of the reactions that you have done in your syllabus for class 11th. Any such reaction where directly hydrogen was coming in place of halogen? And if you can't think of any such reaction, then there is one more way of doing it. We can convert this to alkene first. If I can convert it to ethene, and then ethene will be converted to ethane. We already know how to do it. Hydrogen in the presence of catalyst. Now, what should I add here in the first step? This becomes a two-step conversion for me. So, dehydrohalogenation, if you remember. We add alcoholic KOH. That will be removing hydrogen and Cl from here, and you will be getting this alkene, which will give you the corresponding alkane. Again, it becomes simple conversion. Now, this everyone can do now. I'm sure about it. If you are doing all the conversions with me by writing, as I am doing, you'll be very comfortable by the time we reach the middle of this presentation. So, chloroethane, CH3, CH2, Cl. It is to be converted to butane. Again, I can see the number of carbons are doubling. 2 carbons and here 4 carbons. So the answer is very clear. That is, we are going to take sodium metal in the presence of dry ether. Sometimes they will give you a particular conversion, maybe just half of it with the reagent and the reactant that you need to carry out the reaction. They will ask you to complete the reaction and identify the name reaction involved. So here it is very clear. The name reaction which is involved is Wood's reaction. Next, ethanoic acid to methane. Let's write the formula. Ethanoic acid is to be converted to methane. Now, if somehow I can remove the CO2, I will be getting methane. Clear? And how can I do that? I can simply do it by, you remember, I hope the removal of CO2 is called decarboxylation. So, for decarboxylation, you treat the carboxylic acid with sodium first, NaOH, sodium hydroxide. it will be giving you CH3COONA, and then it is further treated with NaOH in the presence of calcium oxide, and we heat it. So by this reaction, the CH3CONA straight away converts to methane, which I wanted to make. This second step, you have two steps here. This is the first step, and in the second step here, basically we are removing this COO with the help of more NaOH. So this reaction is decarboxylation. Decarboxylation. Wherever you have this DE written, dehydration, decarboxylation, dehydrohalogenation, for example, that means removal of that particular molecule. So decarboxylation is removal of carbon dioxide. We remove CO2, we get CH3NH, that is CH4. Dehydration, you make use of in some other reaction, some dehydrating agent like concentrated sulfuric acid. So that is removal of water. Dehydrohalogenation, as we did in the previous reaction, a removal of hydrogen and halogen along with that, where we use alcoholic KOH. So simple reaction again. Then if you have to convert ethanoic acid to ethane, in the previous one we converted ethanoic to methane, so we just removed CO2, decarboxylation. And if you remember, here also there is one more decarboxylation, that is Kolb's electrolysis. This we have done in class 11th only. Kolb's electrolysis. So what happens in Kolb's electrolysis? We start with 2 carbons here, and in the product also you get 2 carbons. This is electrolytic process. Here also you will be reacting the CH3COH with NaOH, and you will make use of electric current. And you can mention that it is Kolb's electrolysis. In Kolb's electrolysis, if you see the mechanism carefully, I have discussed the mechanism on my channel in some other presentation. You can see that. So straight away, if you mention Kolb's electrolysis here, it will be giving you the product with same number of carbons as here. Now, ethyne, that is alkyne with 2 carbons, to ethanol, CH3CHO, ethyne to ethanol. In this particular conversion, I have to bring oxygen here. Simply hydrogenation, addition of hydrogen will not help. So I'll start with something which has oxygen in it. If you remember the tautomerism reaction, we are going to use that here. Let us see. Here you will be treating it with H plus and water. You will find Hg2 plus also written. The reaction is this only. Basically the water molecule is used in acidic medium, which is going to add here on the double bond. So it will give me CH2 double bond CHOH. This is called enol. En for double bond and all for OH functional group. This undergoes a particular type of isomerism called tautomerism. This bond will shift here. It will convert to C double bond O, and simultaneously this pi electron density will shift here. So carbon will get a negative charge and this H plus will go to that carbon. So it gives you CH3 C double bond OH. This particular step here, which we are discussing, this one. This is called tautomerism, because this isomerism from enol is converting it to aldehyde form. And in some other cases where you have more than 2 carbons, you will get ketone. So keto-enol isomerism or tautomerism we generally call it. So what did we do exactly? Just to tell you once again, we had ethine. We provided in the presence of Hg2 plus acidic medium water, and it gave you CH2 double bond CHOH. And from here isomerism started. So it provided CH3 CHO. Next, propyne to propanone, and the common name of propanone is acetone. Propanone is the IUPAC name. Propyne is alkyne with 3 carbons. And propanone or acetone is this. Again tautomerism. If you try it, you'll find that here you have H plus water. It gives you CH2 double bond COH CH3 enol. And in case of enol, as I told you here, this shifts here, this shifts here, and it produces CH3 C double bond O CH3. I have got the required product, acetone or propanone. You go slow in the beginning, you can stop the presentation anywhere, write with it. And conversion is the best way of assessing whether your organic chemistry is properly, fully prepared or not. If you are not able to do conversions, that means you need to go back to the chapter of organic chemistry and thoroughly do it again. And then this is the last part, application part. You'll be able to do it easily then. Next is propene to ethanol. Let's see. Propene is alkene and I have to convert it to an aldehyde ethanol. How do I do that? Tautomerism will not help because the number of carbons are decreasing. Here you have 3 carbons, here you have only 2. So whenever you have an alkene and the product has C double bond O in it, think of ozonolysis. Treat it with ozone. It will give you CH2 ozonoid. Show it like this. And then treat it with water. It will be giving you CH3 CHO plus from here you will get HCHO. But in conversion, you write only that product which has been asked in the question. No need to give byproducts. I'll tell you one more important thing here. Once again, you do not need to show ozonoid formation in conversions always if it is not specified in the question. Just take the starting material, show ozone, H2O, and in the product you just have to remove this double bond and put double bond O, double bond O. So these will be your 2 products. What am I saying? Let me explain again. I am saying you had propene, you treated it with oxygen, hydrolysis. It will give you CH2, remove this double bond, put double bond O, plus same way double bond O on the next carbon which was involved in the double bond, CH3 CHO. So this was the desired product, ethanol. We have got it. The same conversion can be given as propene to methanol. And you will notice in the same reaction you have methanol. Same reaction, then you specify this product. So in conversions, you do not need to give all the byproducts. Just give the product which has been asked in the question. Even if it is a minor product, just mention that. Whenever you have, before taking up this particular conversion, whenever you have to explain ozonolysis, whatever alkene is given to you, no matter what is attached here on carbons, just remove this double bond O when you show ozonolysis and put double bond O plus this. These are the two products. And if you have to go back, if the opposite is asked, if they are asking you that these are the products and what would be the starting material alkene, just remove this double bond O and attach these two carbons with each other via a double bond. That would be the alkene. Simple. Okay. Next is ethene to methanol. Ethene, CH2 double bond CH2, methanol. We can write it like this or we can write it like this. I hope you can answer this. Again, it is ozonolysis. Simply ozone followed by hydrolysis. It will give you CH2O, CH2O. So basically you are getting 2 molecules of methanol here. Again, if you do not write this 2, it is okay. Here balancing is not mandatory. But it is very clear, 1 molecule of HCHO will come from here and 1 will come from here. Just remove the double bond, put double bond O on this carbon and this carbon. They are the products. Now, N-butane. It seems a very difficult one from the names here. If I have problem with IUPAC, I might get stuck here. N-butane, N, small n is normal. That means straight chain, no branching. It is simple butane. And it is to be converted to isobutane. Iso means 2 methyl groups on the same carbon in structure, or it is also called 2 methyl propane. So propane would be 3 carbons and I have this. I have CH3, CH, CH3. So here you have 3 methyl groups on the same carbon, and whenever you have 3 methyls on the same carbon, that is generally called neo. But in many books you will find this isobutane, so that is this. Okay, 2 methyl propane is called isobutane also. Okay, why iso am I calling it? Because you have this carbon attached to at least 2 CH3. So this becomes iso group, and after that the remaining carbons are attached here to get the corresponding alkane. So it is butane, so only 1 carbon is left. So this becomes the compound isobutane. Now how to do this conversion? One thing you will notice that this is also alkane and the product is also alkane. So if you remember how to carry out isomerization, which is explained in your NCERT, you simply take the starting material and you heat it in a closed container with anhydrous AlCl3. No other reagent required. And the rearrangement will take place with the help of this catalyst, and it will give you the corresponding isomers, different possible isomers. So the isomerization is taking place and you are getting the required product. Now, interesting, propene is to be converted to 1 bromopropane, that is CH3, CH2, CH2, Br, and in the other one 2 bromopropane, that is CH3, CH, Br, one more CH3, 2 bromopropane. Clear? Simple. Here I have to bring Br on the first carbon, here on the second carbon according to Marconic oxidation. So let us write them separately. Propene, when reacted with HBr in the absence of peroxide, the negative part of addendum is going to the carbon with lesser number of hydrogens. So this is the major product, right? So if they are specifying only 2-bromo, you go for this. And in the other one, if they ask you for 1-bromo, that will be against the Marconic oxidation. So I will say that I am taking HBr with peroxide. You can write benzoyl peroxide here, that's better. To make it clear, mechanism I have discussed in another video in the same on the same channel. It has been uploaded. So CH3, CH2, CH2, Br. 1-bromo. The negative part, that is Br minus, is going to that carbon which has more number of hydrogens. Anti-Marconic oxidation. Simple again. I am discussing all those conversions which I think are appropriate to start with at class 11th level. 1-bromopropane, right? This is 1-bromopropane. It is to be converted to 2-bromopropane. Actually interesting. Okay, so here I will first remove this Br from here. So removal of halogen along with hydrogen is dehydrohalogenation, alcoholic KOH. It will give me CH3, CH, double bond CH2. And from here I have to get 2-bromopropane. So I will add HBr again. Negative part of addendum goes to that carbon which has lesser number of hydrogens, and I got the product. Simple 2-step conversion. Yeah, and if we go back means this conversion. 2-bromopropane to 1-bromopropane. Let us see. 2-bromopropane, I am talking about this conversion. Is it possible? 2-bromopropane, remove halogen, CH3, CH, double bond CH2. And then I want Br on the first carbon. Yes, it is possible. HBr in the presence of benzoyl peroxide. So I'll get 1-bromopropane. And I hope you remember that only HBr follows anti-Marconic oxidation. Another reasoning question, very important, HCl and HI do not follow anti-Marconic oxidation. So it is possible only with HBr. Ethyne to propyne, interesting again. Ethyne to propyne. Now in your book, you will never find a reaction which is straight away giving you this conversion. You have to think of different reactions that you have done. And if out of them any reaction, different reactions which can be used here, it may be more than one possible ways of doing it, but the correct way. You can reach to a particular destination from here to here by different routes, isn't it? So we generally choose the shortest one. Here also, I have to keep the triple bond intact, but I have to increase the number of carbons by 1. Whenever increase of carbons comes in a particular conversion, Wood's reaction comes into mind, but that will not help here because I have ethyne with me. I do not have haloalkane from which the Wood's reaction starts. And there the number of carbons double. Here it is not doubling, it is just increasing by 1. So I have to think of something else. Let us see what would that be. That is going to be this way, that I will first take advantage of the acidic nature of this and I will convert it to sodium ethionite. I hope you remember in this case hydrogen gas is liberated and this acidic hydrogen is replaced by sodium metal. So sodium ethionite. Now I can treat it with CH3Cl. And now it is clear. This NaCl will be removed and it is giving you the desired product. Same way, if you want to increase the number of carbons by 2, 3, 4, 5, 6 and keep the triple bond intact, change the R group here and you will get the desired product. I hope I am able to explain the conversions to you in a way that you wanted, easy manner. And if you do it by writing, believe me, by the time you reach end of this presentation, you'll be confident about conversions. Ethyne, which is also called acetylene, common name, to benzene. Ethyne to benzene. Aromatization from aliphatic compound, we are converting it to, we are reaching aromatic compound. So here it is cyclic polymerization. We write 3 molecules of ethyne like this and then we show cyclization. That is, we show it like this, this, this. For that you need to pass this ethyne through red hot iron tube at 873 Kelvin temperature at least, and this cyclization will give rise to benzene. There is one more question here in your NCERT, that if you start this reaction with propine, what would be the product? So in case of propine, you will have CH3, CH3, CH3 on alternate carbons. And one more question that comes to my mind is that if you have to make toluene here, toluene is benzene with CH3. Methyl benzene is called toluene. So is it possible to make it by this way? No. In this case, if you remember, there is one more preparation of benzene in your syllabus in which you start with N-hexane and you carry out oxidation in the presence of chromium oxide or manganese oxide, vanadium pentaoxide, any of these oxidizing agents at very high temperature and pressure, vigorous conditions. So that produces hexane, produces benzene. If you want toluene, then you have to start from heptane because these 6 membered rings are very stable. So that will be the product. Next is benzoic acid, benzene with COH. Benzoic acid to benzene. Same thing as we did for ethanoic acid to methane. Get rid of the CO2. Same way, treat it with NaOH, you will get this. And then NaOH, calcium oxide, heat it, you'll be getting the benzene because the carbon dioxide will be removed. So I will call this decarboxylation. Phenol to benzene, simple. This is phenol. I have to convert it to benzene. So I have to remove the oxygen which is here. I will get C6H6. For that, you can simply heat it with zinc. It will give you benzene along with zinc oxide. So this is the product that I wanted to make. Benzene to nitrobenzene, another interesting one. I hope by the time you reach the end of this presentation, you will start enjoying conversions. It is like maths. Once you understand the concept, then you need more questions for practice and you ask for more, that give me more questions. I have understood. I want to apply. Same thing here. Benzene to nitrobenzene. This is called nitration. Nucleophilic substitution reaction. Simple one. So I will be taking nitrating mixture. Nitric acid, sulfuric acid, concentrated, both of them, and it will give you NO2 because this combination of HNO3 and H2SO4 produces NO2 plus electrophile. That will attack on benzene and you will get this Three-step mechanism we have discussed in class also, and again I have put a particular presentation related to that three-step mechanism, electrophilic substitution, so you can revise it from there once. In conversions, you do not need to give the mechanism and all that. That's a separate question, and they will specify in the question if they want that. In conversion, which is generally one marker, one step, two step, maximum three, which is very rare, just show the reactions like this. Benzene to chlorobenzene, another electrophilic substitution reaction. Benzene to chlorobenzene. So you will take chlorine with the help of anhydrous AlCl3 catalyst. You will carry out the simple reaction. Straight away it will give you chlorobenzene. Simple. Benzene to toluene. So here, what are we doing? We are bringing one alkyl group here on benzene. This is called alkylation. Like putting chlorine here is halogenation, specifically chlorination. This is alkylation. Alkyl group is coming. So you will go for Friedel-Crafts alkylation. I want CH3. So I will take CH3Cl with anhydrous AlCl3. And it will give me the desired product, that is CH3 electrophile will attack on benzene and I'll get the product. Benzene to para-nitrotoluene. Now toluene we know CH3 on any carbon and its para position should have nitro. Now there are two groups which are to be brought here. One is methyl group, another is nitro. If you bring nitro first, it is electron withdrawing group. It will bring the next incoming group, which is methyl here at meta position. Because electron withdrawing groups are meta directing. So I don't want that. I want para position. So I will first bring methyl because our groups are electron donating groups. They will bring the next incoming electrophile at para position. So we start with alkylation. Benzene is to be treated with CH3Cl, anhydrous AlCl3 as catalyst. It will give you toluene and then you carry out nitration using the nitrating mixture, this plus concentrated sulfuric acid. It will give you NO2 at para position, so you will get this product. Benzene to meta. Now see, we need meta. Benzene to meta-nitrochlorobenzene. So benzene, on any carbon you put nitro and meta. Next two positions are ortho, next two are meta and the exactly opposite is para. I hope you remember all that. Ortho, meta, para. So you will start with benzene and you have to make, I am drawing it again. Suppose I put nitro here, then meta of that, ye ortho, ortho, meta, meta. So I can put it here or that this side, chloro and benzene. This is the product. Now if I bring chlorine first, chlorine is electron donating group as far as resonance is concerned. So it will bring the incoming electrophile at ortho or para. I want it at meta. So I will be bringing NO2 first because this is electron withdrawing group. It will bring the next incoming electrophile at meta position. All the reactions may not be practically so feasible, you know, but if such questions are asked, then technically this is how you explain it. You will first bring nitro group here. So HNO3 and H2SO4 both concentrated. It will give you nitrobenzene and then you treat it with chlorine in the presence of anhydrous AlCl3 catalyst. So the next electrophile comes at meta position, and you get the product meta-nitrochlorobenzene. Benzene to para-nitro. Now this is same as para-nitrochloro. Easy now. Benzene, para. So you need to bring bromo first, not nitro. Catalyst, bromo, and then nitration. Yeah, simple conversion again. I hope it has become simple. This I think we have discussed. Okay, let me just, yeah, it's okay. Even if we do it again, it will give us practice only, so doesn't matter. Benzene to para nitro. So para, I will not bring nitro first, I will bring toluene. I will bring CH3 anhydrous AlCl3. Friedel-Crafts alkylation. I am getting CH3, and then you treat it with nitrating mixture. This mixture produces NO2 plus, the electrophile. So that will attack at ortho as well as para, two products. But you have to write only that which has been asked. Benzene to acetophenone. Now, what is acetophenone? Very commonly used name, common name for COCH3. This is acetophenone. That's a ketone, clearly a ketone. So here I will carry out the reaction as Friedel-Crafts acylation. CH3 COCl, because I want CH3CO, I want this, and in the presence of anhydrous AlCl3 as catalyst, it will straight away give me acetophenone. If you go for the IUPAC name, it is 2 carbons ketone, which is otherwise practically not possible. The chain is of 2 carbons, and here also you have carbon, so it's clearly a ketone. It becomes 1, 2, 1 phenyl ETHANOIC. That's the ketone. Then you have benzene to N-propyl benzene. Benzene. What is N-propyl benzene? Normal, straight chain. So the propyl group is like this, no branching. It's a straight chain. Again, Friedel-Crafts alkylation. So I want straight chain. What will I start with? I will start with the CH3, CH2, CH2, Cl. So that it breaks from here, and this carbon gets attached to benzene in the presence of anhydrous AlCl3. Friedel-Crafts alkylation, where this is the alkyl group. Another one, same concept, benzene, isopropyl. Iso, again the carbon attached to 2 methyl groups. So this is isopropyl. Now I want this alkyl group. Again Friedel-Crafts alkylation only. But now I will start with CH3, CH3, Cl. So that it breaks from here, and this carbon gets attached to the carbon of benzene. And this will carry out in the presence of anhydrous AlCl3. So again it is Friedel-Crafts alkylation. This, in the presence of this, will give you this product. As simple as that. So I hope the conversions that I have discussed today, they are going to help you. Prepare well. Any subject, do it by writing so that it is retained in your mind for long. All the best. Thank you.